Hello all, and welcome to my humble corner on the internet. You may have found this video from following a link on my WordPress blog, or you may have found it in a frantic Google search regarding today's topic. Either way, it's nice to have you here. Today I'd like to review object-oriented programming concepts. Many languages today are object-oriented, and the concepts are universal in that way. Some popular examples of object-oriented programming includes, but are not limited to, Java, Python, and C++. For today's video, we will be focusing on our examples in Java. By this point, you might be wondering, what exactly does object-oriented programming mean? At its core, object-oriented programming follows the natural logic that humans tend to follow when regarding things. Everything can be considered an object with different attributes and behaviors, which tells us how to interact with them. Consider the following things: a bicycle and a car. They are both modes of transportation, and there are a few differences and similarities. Pause the video and see how many attributes you can find for each. Okay? You had enough time? Let's see what I have. For the bicycle, we have the attributes of wheels, handlebars, pedals, and a seat. For the car, we have attributes of wheels, windows, seats, and an engine. Since we know the bicycle has pedals, we know that we must sit on the seat and turn those pedals to make the wheels turn and move the bike forward. Since the car has an engine, we know that we must sit in the front seat and push the pedal to prompt the engine into turning the wheels and moving the car forward. There are 4 pillars that support the use of object-oriented programming languages. Commonly known as APIE, they are rules which guide the successful use of object-oriented programming languages. APIE stands for Abstraction, Polymorphism, Inheritance, and Encapsulation. Let's go through these 4 concepts and describe how they are achieved. Abstraction is the process of hiding or abstracting implementation details from the user and the rest of the program. Only the necessary functionality is shown to the user. In Java, abstraction is achieved by using abstract classes and interfaces. Moving right along, we have polymorphism. Polymorphism simply means many forms. It's the basic ability to process objects differently according to their type or class. You can redefine methods derived from the superclass to a subclass. Subclasses can also use some methods in the same way as their parent class. There are 2 kinds of polymorphism: overriding and overloading. For this video, we will focus on overriding. Let's get into an example. In this example, we have a public class titled Animal, and the Animal class has a public method titled Eat, which simply prints out a line to the console of "I am eating something." With polymorphism, we can have classes inherit from this class and then give it its own definition. So let's check out dog. Something important to note is that if I did not redefine what eat means and didn't even define it at all within this class, it would still be able to inherit the eats method using the original definition of "I am eating something." But let's give this a different definition. So let's do sysout control space and then "I am eating kibble." And then that's our redefinition of the eat method for the dog class. Similarly, we'll go into the wolf class, and we will type in, again, syso control space, "I am eating caribou." Let's go to cafeteria now. Cafeteria is our main class, which has our main method in it. So as you can see, we are calling the animal is a new instance of our class. So we're calling on the eat method for a new animal instance, a new wolf instance, and a new dog instance. And if we run this, you will see that Using the same method, we are able to print out different lines based on our redefinitions. And in that way, it was able to take many forms, aka polymorphism. Going somewhat hand in hand with polymorphism is inheritance. Inheritance describes the way that you can create a new class from an existing class. This new class, called the child class, inherits properties and behavior from the old class, called the parent class. The relationship between parent classes and child classes can be described as the child is a parent. Time for the next example. Here you see I have a public class of platformer. This public class contains methods which describe common actions in platformer games. So you see here we have public void jump, public void walk forward, and public void run forward. To keep the example pretty basic, I've only had them do system out print line to print a line to the console. Now, if I wanted to create a class that would use these three methods again, I wouldn't have to rewrite this code. I simply have to say extends platformer. So this is my game of Mario, and Mario extends platformer. So now you can imagine that within the class body you would see those three methods printed again, but we don't need to because this does it for us. I've also taken the liberty of giving Mario a unique method of throw file. I've also created another game, Adventure Island, which also extends platformer. Finally, in the game system class, I have my main method where I create a new instance of the Mario class and a new instance of the Adventure class. As you can see, I have jump being called from the platformer class, run forward being called from the platformer class, and walk forward also being called from platformer, and I've also called on throw file and throw axe. So let's see what happens when I run these. Alright, so we've gotten press A to jump from Mario.jump. Mario.run forward has gotten our hold down B and the right key to run forward. And Mario throw file has come from its own definition to press B to throw a fireball. In this way, we've avoided rewriting a whole lot of code, keeping the code neat and precise. Last but not least is encapsulation. Encapsulation may feel a little bit like deja vu. It's somewhat similar to abstraction. Like abstraction, it hides implementation details from the user. Unlike abstraction, however, the hiding is done via restricting access to public methods. Methods and variables are bundled together as a class in object-oriented programming, and this is the pillar which makes that happen. It is also within encapsulation where private variables come in. Only objects in the class which have that private variable can access it. And that's pretty much the object-oriented programming concepts, APIE, in a nutshell. Please feel free to follow my GitHub, my WordPress, or both, provided in the description below. Thank you for watching and have a good day.